So last time we looked at an example of how we could use linear algebra to solve or get relationships between stress and strain for linear, elastic, isotropic, cubic materials. But how do we look at materials that are not linear elastic, that are anisotropic? Basically, where the stiffness will vary depending on the direction of the applied stress or strain. So we will actually have to use a more general expression. So we'll have to relate a second-rank tensor property in stress or strain to, again, respectively strain or stress via these fourth-rank tensor properties. This is C, this is your stiffness tensor. S is your compliance tensor. Again, confusing, but I didn't make the notation. I'm just following it. And one of the ways that we can kind of write relations between these is using this, again, reduced 1/6 notation in this Voigt notation. So we can rewrite these, and again, we could write basically a linear algebra relationship between the two. So we can see here, I can write strain as a function of stress, and I can relate it by this 6x6 matrix. Because remember, I need the dimensions to make sense. So I cannot dot basically 6x6 by a 1/7. I need those columns and rows to match up. So I need to now, and I can, again, based on our assumptions of static equilibrium, sum of the forces, sum of the moments must be equal, I could build a 6x6 that is also symmetric. So because this is symmetric, because this is symmetric, this must be symmetric as well. And you'll see that for cubic materials, the number or the kind of unique values in this tensor can change depending on the symmetry. So cubic has the most symmetry. It's going to have the least independent number of these variables here, and the same thing for this transversely isotropic materials. So when you get into these problems, you'll kind of see, and you could, again, if you're given stress and strain, you could use linear algebra to work with this. So next time we're going to get into plane stress, and how do we actually rotate these states. Thanks. See you next time. Bye.